Hi, welcome to our CompTIA Network Plus course. In this lesson, we will talk about cloud concepts and connectivity options. And we're going to talk about the following topics, such as NFB, VPC, NSG, NSL, cloud gateways, cloud connectivity options, deployment models, and service models. Welcome to this overview of cloud computing, concepts, and connectivity options. We're going to explore key technologies, deployment models, and service offerings shaping the future of ID infrastructure and network management. So, cloud computing has emerged as a transformative technology, fundamentally changing how organizations approach ID infrastructure and service delivery. This section delves into the core principles and benefits of cloud computing, outlining its impact on the modern business landscape. So, what is cloud computing? Cloud computing provides on demand access to a pool of shared computing resources, including servers, storage, databases, networking, and software over the internet. This model eliminates the need for organizations to invest in and manage their own physical infrastructure, allowing them to access and utilize resources as needed, paying only for what they consume. So, what are the key benefits of cloud computing? First is enhanced scalability. Cloud computing enables organizations to quickly and easily scale their resources up or down based on fluctuating demand, ensuring optimal performance and cost efficiency. Then you have cost savings. Cloud services offer a pay as you go pricing model, reducing upfront capital expenditure and operational costs associated with traditional IT infrastructure. Then you have increased agility. Cloud platforms allow organizations to deploy and manage applications and services faster, accelerating innovation and time to market. Now let's talk about NFB, or the Network Functions Virtualization. NFB represents a paradigm shift in network infrastructure management, transforming traditional hardware bound network functions into software defined entities. NFB virtualizes network services that were traditionally run on specialized proprietary hardware, decoupling these functions from dedicated appliances. This virtualization enables network functions to be executed on industry standard servers and significantly enhancing flexibility, reducing costs, and accelerating the deployment of new services. NFB offers a multitude of benefits, including the following. First is decoupling. So NFB separates network functions from the dedicated hardware. Then you have virtualization, which means functions can run on standard servers as virtualized entities. And third is flexibility, where you can easily scale and adjust network resources based on demand. Now let's talk about VPC, or the Virtual Private Cloud. VPCs create isolated networks within public cloud infrastructure. This isolation provides a layer of security and privacy for your applications and data, separating them from the other tenants on the same cloud platform. VPCs allow you to define your own IP ranges, subnets, and routing tables, giving you granular control over your network topology. This flexibility enables you to tailor your cloud environment to meet the specific requirements of your applications and workloads. Now, with the VPC, you have the ability to manage network resources and traffic flow within the cloud. You can set up firewalls, configure security groups, and control access to your resources, ensuring that only authorized users and applications can interact with your network. Network security groups. Network security groups act as a virtual firewall, controlling inbound and outbound traffic to cloud resources. They provide rule-based control, allowing you to apply security rules based on IP address, port, and protocol. This granular security enables you to define specific rules for sensitive applications or services, enhancing the overall security posture of your cloud environment. NSGs function as virtual firewalls, controlling network traffic to your cloud resources. NSGs allow you to define security rules based on IP addresses, ports, and protocol, enabling fine-grained control over network access. NSGs provide granular security by allowing you to define specific rules for sensitive applications or services, ensuring that only authorized traffic can access them. Let's talk about NSLs, or Network Security List. NSLs are a fundamental component of cloud security, providing subnet level security policies. These policies are applied to the entire subnet and ensuring that all instances within that subnet inherit the same security rules. NSLs offer a granular approach to controller network traffic by defining rules that specify which traffic is allowed or denied. These rules are based on source and destination IP addresses, ports, and protocols. By implementing NSLs, you can effectively restrict access to your cloud resources, enhancing security and compliance. Here, we have a couple of subtopics within NSL. First one is scope, where we define the subnet level security policy. The applications where is about the rules that apply to the entire subnet, right? And inheritance, instances inherit the subnet security rules within the VPC. Cloud gateways. Cloud gateways act as bridges connecting on-premises networks to cloud environments, facilitating seamless communication and data exchange. They provide a secure, controlled environment for cloud traffic, ensuring data integrity and compliance with security policies. One of the key advantages of cloud gateways is their scalability. They can adapt to increased traffic demands seamlessly, ensuring optimal performance even during peak usage periods. This scalability is important for businesses that experience fluctuating traffic patterns or anticipate future growth. Let's talk about Internet Gateway. The Internet Gateway enables communication between resources within your VPC or the virtual private cloud and the Internet. And this allows your VPC instances to access external services and resources. The Internet Gateway provides NAT or Network Address Translation, which translates private IP addresses used within your VPC to public IP addresses for Internet access. And this allows your VPC instances to initiate outbound connections to the Internet without exposing their private IP address directly. The Internet Gateway facilitates efficient routing of traffic between your VPC and the Internet. It handles the routing of Internet-bound traffic from your VPC and directs incoming traffic to the appropriate resources within your VPC. NAT Gateway. Address translation, right? A NAT gateway translates private IP addresses to public IP addresses for outbound internet access. And this allows instances within the private IP addresses exposed to the public. A NAT gateway acts as a security layer, protecting private instances from direct internet exposure. By routing all traffic through the NAT gateway, it prevents attackers from directly targeting private instance. Cloud connectivity options play a very important role in bridging the gap between the on-premises network and the cloud environment, providing secure and efficient data transfer. These options offer various advantages, and each catering to specific network requirements and organizational needs. This lesson will explore the key benefits, features, and considerations for each connectivity approach. First one is VPN, or the Virtual Private Network. VPNs utilize encrypted tunnels over the public internet to establish secure connections between networks. They offer a cost-effective solution for moderate bandwidth requirements, making them suitable for scenarios like remote access or connecting branch offices to the cloud. VPNs are generally easy to set up and manage, and they can be scaled to accommodate moderate traffic volumes. However, VPNs can be susceptible to performance issues due to network congestion and latency, especially for large-scale data transfers or real-time application. Now, direct connect establishes dedicated private connections between your on premises network and the cloud provider. This dedicated connectivity offers higher bandwidth and lower latency compared to VPNs, making it ideal for enterprises with demanding data transfer needs. Direct Connect provides a robust and reliable connection, ensuring consistent performance for mission critical applications or large scale data migration. However, Direct Connect requires a significant upfront investment and comes with recurring costs, making it a more expensive option compared to VPNs. It also involves a more complex setup and management processes. Virtual private networks, again, are a fundamental cloud connectivity option, establishing secure connections between on premises and cloud environments over the public internet. They achieve the security through encryption, safeguarding data transfer from unauthorized access during its journey across the internet. And this makes VPNs are essential tool for organizations looking to extend their network infrastructure into the cloud, ensuring data integrity and confidentiality during transit. Now, VPNs are particularly advantageous for their cost, effectiveness, and flexibility. They provide an economical solution for moderate bandwidth requirements, making them ideal for scenarios like remote access, like connecting branch offices to the cloud, or even serving as a backup connection in case of primary network failures. However, it's important to note that VPNs can experience performance limitation due to network congestion and latency, which might pose challenges for applications demanding high bandwidth or real-time responsiveness. There are different key types of VPN. First one is site-to-site VPN. This type of VPN connects entire networks, establishing a secure connection between your on-premise and the cloud environment. It allows for seamless communication between devices and applications located within both networks. Then you have C2S, or the client-to-site VPNs, which enables individual devices to connect securely to a network, offering remote access to resources hosted on the network. This type of VPN is commonly used by employees working from home or traveling who require access to company resources. Now, with the Direct Connect establishes the private network link to the cloud provider. It also offers higher bandwidth and lower latency than VPNs, and it provides stable connectivity for critical applications. Now let's talk about the cloud deployment models. Cloud deployment models represent distinct approaches to deploying and managing cloud infrastructure, and each offering unique advantages in consideration based on specific organizational needs and technical requirements. Understanding these deployment models is essential for making informed decisions about how to leverage cloud computing to achieve optimal results. This section delves into the key features, benefits, and consideration of each deployment model. The first is the public cloud. Public clouds provides computing resources and services over the public internet, making them highly accessible and scalable. This model offers a cost-effective solution for a wide range of applications and workloads. Public clouds are ideal for organizations seeking agility, flexibility, and pay-as-you-go pricing. Popular public cloud providers include AWS, Azure, then you have GCP, the Google Cloud Platform. Next one are private clouds. Private clouds offer dedicated cloud infrastructure tailored exclusively for a single organization. And this model provides a high degree of control, security, and customization, ensuring complete isolation and data privacy. Private clouds are particularly suitable for organizations with strict compliance requirements or sensitive data handling needs. They often involve significant upfront investments and require dedicated IT personnel for management and maintenance. The third one is hybrid cloud. Hybrid clouds combine the benefits of both public and private clouds, providing a flexible and adaptable approach to cloud computing. This model enables organizations to run workloads in the most appropriate environment, leveraging the cost effectiveness and scalability of public clouds while maintaining the security and control of private clouds. Hybrid clouds offer flexibility in migrating workloads between environments, optimizing resource utilization, and ensuring business continuity. Let's talk about the cloud service models. Cloud service models are fundamental concepts in cloud computing, defining different levels of abstraction and service offerings. They represent distinct approaches to accessing and utilizing cloud resources, in each catering to specific needs and requirements. Now, understanding these service models is important for organizations seeking to leverage the benefits of cloud computing effectively. The first model is IaaS, or Infrastructure as a Service. Let's look at this. IaaS provides virtualized computing resources such as servers, storage, right? All of this here, and networking over the internet. It offers the highest level of flexibility and control, allowing organizations to manage and configure their infrastructure. This model enables organizations to provision and manage their own operating systems, applications, and middleware, granting complete control over the underlying infrastructure. IaaS is ideal for organizations requiring high flexibility, granular control, and the ability to tailor their infrastructure to specific needs. The next service model is PaaS, or the cloud or the platform as a service model. So PaaS delivers a platform for developers to build, run, and manage applications. It simplifies the development and deployment process by providing a comprehensive environment that includes the operating systems, middleware, databases, and other development tools. PaaS offers a simplified approach to application development, eliminating the need for organizations to manage the underlying infrastructure. It's particularly suited for organizations focused on software development and deployment seeking to streamline the development lifecycle and accelerate application delivery. The third model is SaaS, or Software as a Service. Here. So SaaS provides ready-to-use applications accessible over the internet. It represents the higher level or highest level of abstraction, offering a fully managed solution with minimal configuration and management overhead. SaaS applications were delivered via a subscription-based model, allowing organizations to access and utilize software without the need to install or maintain it on their own infrastructure. SaaS is ideal for organizations seeking ease of use, rapid deployment, and cost-effective access to software applications. Okay, that's the end of the lesson. Here we spoke about cloud concepts and connectivity options. We also discussed about NFB, VPC, NSG, NSL, cloud gateways, cloud connectivity options, the deployment models, and the cloud service models. Okay, thank you very much for watching the video.